So if it is a huge building and if it is a MNC company work and all, we try to make use of Acro Spans only. And if the span is larger, if it is a small work and all, you don't require Acro Span. A normal runner is enough to take care of it. Hello, my dear students. Welcome back to the lecture. In this lecture, we will see how to put up the beam bottom and the slab centering works, right? So we'll start with that. So if you understand, see, we are done with the plinth beam, then we are done with the concreting of this column, right? And one thing we understood, whenever we do the concreting, it has to up to the beam bottom. So you can see here, see, this is a beam bottom, okay? You can see the horizontal element here. You can see something here. So this is called as beam bottom, okay? And this is a column top, right? So over this, your beam reinforcement is going to come. Again, you can see all the columns have been, the curing of a column is happening here, right? Yeah. So we'll try to understand all these things in a more better way. Yeah. So you can see it here. See, now if I go back, see, these are called as props. We are going to give these props to support this beam bottom, and my column was casted up to here. See, actually the thing is your column should have been casted up to this height. Okay, this would be the total height of your column. But since I have a beam coming here, that is why what I have done, always I'm going to cast it till the bottom of this. Okay, actually you see this column should have casted here. You can see this column, isn't it? Where this column is casted, this column top height and the beam bottom is exactly at the same level. Whereas this column should have been casted up to this level, but still they have not casted it. But there is no problem in that. Even if you cast, like I mentioned, if you remember, even if you do the casting of a column 50 or 100 mm less than the beam bottom, no issues. But column should not be casted above the height of the beam. I mean above the bottom height of the beam. Why? Just in case, let us consider instead of this, I had casted my column up to this level. Okay, then what would have happened? What would have happened? So when you come to place this particular beam bottom, you can place the beam bottom here. I mean the beam reinforcement. Yeah, I hope you'll be able to understand. See, the beam reinforcement has to pass through this column, but by the time it reaches here, it is already a concrete which is casted. You cannot insert your beam inside, right? So then what you should do, you should chip off this extra portion. Whatever extra portion you have done, no, that much you have to take it out. For like in this way, you have to take it out. That means again additional cost will be involved to chip that. That is why I told you always cast it up to the beam bottom, else even 50 or 100 mm less is good. Got it? So that is a practical importance of it. Yeah. Yeah, you can see. So this we call this as a beam soffit, or sometimes we can call this as a beam bottom. One and the same. Okay, this is called as beam soffit or beam bottom. You can see here also know how they have placed it. Okay, and these are the props what we are going to give. Yeah, so you can see how it has been done completely. So this distance what you're supposed to keep, there is no hard and fast rule. A few people do in their own way, but I feel 600 mm center to center distance, that is from this prop. These are called as MS props. I'll write it here if you're not able to pick me. It's called as MS. MS is mild steel props. Okay, we call this as mild steel props. Okay, and that height will be usually 10 feet. This height will be 10 feet height. Okay, this height will be a 10 feet height. Yeah, so this center to center distance you can keep 600 mm. Even a 500 mm is also good spacing to be kept. Okay, yeah. Yeah, now you can see exactly what I was trying to tell. See, the column has been casted up to this side, and see where exactly we have placed the beam bottom, isn't it? Again, these are the props what we are given to support it. I'll explain you through a video how all these things are arranged practically on the side. First, we'll try to understand the concepts here. Again, the one you can see here, right? These are called as runners. So these are called as runners. We'll keep the runners, and then the U-head jack will come, and then the MS props is going to come, right? Yeah. Yeah, next, once that is done, next is arranging the beam inner side shuttering. So far we had put the beam bottom, isn't it? In the same way, you have to put the shuttering. See, I'm using a two words now. One, I'm using a beam bottom. Second, I'm telling beam shuttering. Why I'm calling beam bottom? Because it is a horizontal element. I'll not call it as shuttering. But whereas the beam sides, this is a vertical element. So I'm calling beam shuttering. Okay, you can see here the bottom was put up. You can see even the sides are being put up. You can see these sides. So these are called as beam sides. Even here also you can see that, see, the bottom was fixed, and these are the side shuttering for the beams. Now to put it in a better way, this will be the breadth of your beam, and this will be the depth of your beam. Got it? And from where do you get all these things? Again, you have to refer a ground floor layout, and in there all these details will be written. We'll try to see all those things. Yeah, now you can see I think by this time you got an idea. You had casted the plinth beam, you had put up the props, beam bottom was put up, and along with that, these are the beam side shuttering what we have put up, and these are the slab centering plates which I'll be taking next. How to put this beam centering. Up to here, I hope your concepts are clear. Yeah. So now you can see these are the. Now let us consider I have a beam size B1. The name of the size of the beam is 230 by 450. So this width what you can see, the beam bottom width, that will be your 230 and this will be 450 mm. Got it? Yeah. Again, you can see these are the beam inner side shuttering. All these are the beam inner side shuttering. And we call this as a U-head jack because it will be a U in shape. So that is why we call this a U-head jack. So props will be there. Over the props, your U-head jack will be there. For that, we are going to put the runners, and over that, your beam bottom is going to come. And you can see a kind of a steel element here. So this is called a shikanja. So this particular thing is called a shikanja. I'll write it here. Shikanja, or you can call this as a clamps also. Okay. So through this, what will happen? The beam bottom is going to get very rigid support through that. Okay. So that is why at regular intervals, we are going to keep this beam, this shikanja or clamps. You can see here also, right? You can see here also. And here also you can see all these things. We'll see through a video how they are going to place all this shikanja, right? Yeah. Yeah. Finally, you got an idea how it is kept. So now this is my beam inside shuttering. See, whenever you understand the beam, you have to understand two things. We'll have an outside shuttering and we'll be having an inside shuttering. Now, if I take this particular column, outer, like from here, we don't have any other slab. So whatever shuttering I put here, no, it becomes my outside shuttering. Whereas if you look into this particular beam, we have a slab in this portion, we have a slab in this portion. Now this becomes my inside shuttering. If you have a slab on both the side, it becomes my inside shuttering for the beam. If once, like if I have a beam here and I have only slab in this portion, I don't have any other slab, then this particular portion will become my beam outside shuttering. Got it? So that is why all the outer side, you're going to get the beam outside shuttering. And this is your inside shuttering, right? And we'll see what is the difference between the outside shuttering and the inside shuttering. Yeah. Now again, can you identify what kind of shuttering is this? Of course, this is the inside shuttering. Why? Because here also slab will come and here also slab is going to come. So this becomes my inside shuttering. Yeah. Now you might have got a complete idea now. See, we had put the beam bottom. This is my shuttering. This is my shuttering. And in this portion, no, what is going to come? Your slab centering plates are going to come, right? So in this portion, I don't have any other slab. So this becomes my outside shuttering. Here also it becomes my outside shuttering. Got it? Yeah. Similarly, you can see it here also. Yeah. Finally, once everything is done, this is how it looks. Beam bottom you had arranged, beam outside shuttering, inside shuttering and all. And finally, it's going to look in this way. So once that is done, next we have to make use of the acro spans, right? Because if you want to keep your slab centering plates, you have to make sure that you're using an acro spans. So you can see here. So these are called as acro spans. So this is available in 2 meter or 3 meter length. This length, whatever you have, no, it's a 2 meter length. And when you stretch it, it's going to become a 4 meter length. Got it? So this is how it looks. Yeah. Now what we do, you can see we had arranged the beam bottoms and all. You can see here, no, we have kept one runner here. We have kept another runner here, another runner here, another runner here, here, and here, right? And we have given the connection with the help of a MS props. Now over this, you are going to keep those acro spans. Yeah, over this, here to here, we are going to support one acro span. From here to here, I'm going to support another acro span. From here to here, another acro span. And from here to here, another acro span. And then whatever is a slab centering plates, isn't it? You're going to keep your slab centering plates over this. Got it? So in this way, you have to arrange that. So in most of the bigger construction companies, we make use of acro spans. If acro spans is not available, then you can put the same runners in this direction. Instead of acro spans, you can keep the runners in this direction. The runners, whatever you get, no, you can arrange in this way. So if it is a huge building and if it is a MNC company work and all, we try to make use of acro spans only. And if the span is larger, if it is a small work and all, you don't require acro span. A normal runner is enough to take care of the load. So I'll be showing you all those things. Yeah. Now you got an idea. See how we have kept the acro spans here. So this is one acro span. You have kept another acro span here. Then another acro span here, isn't it? So in this way, you have to keep the acro span. And once you can see here also, this is one support. This was another support, right? And over that, I'm going to keep my acro span. And once you keep the acro span, then you're going to keep the slab centering plates over that. So it will be easy for you to support your slab centering plates. Yeah. So for the slab centering plates, these are the centering plates what is available. We call this as a steel shuttering plate. So the size of this will be 2 feet by 3 feet. That means, so this is 2 feet and this is 3 feet for us. Got it? So these are the standard size what is available in the market. So with the help of this, we are going to arrange the slab centering work, right? Because we had kept 2 acro spans, isn't it? This was 1 acro span, this was another. So in between these 2 acro spans, I'm going to keep my steel, steel centering plate, so that will act like a base for the slab. Yeah. So like I mentioned, see here, these people have not used the acro span, but they made use of a runners, isn't it? You can see there's no acro span here. So what they have done, this is one support. Here they have put another runner. Here they have given another runner. And over that, they are going to keep the slab centering plates, isn't it? So that is also okay, provided if it's a small construction, then we go with the runners. But if it is a big construction, like I mentioned, then acro span is always good. And since acro span is made up of steel, it's going to take a huge amount of load, right? So that is why we make use of the acro spans. You're getting my point? So look how he is arranging it. He has kept it here. He has kept it here, and then he's going to arrange the slab centering plates. One thing you need to understand, I told the size of the centering plate is 2 feet by 3 feet. Then you just put your mind and tell me what should be the center to center distance of this from here to here, here to here, here to here, here to here, right? That is the center to center between 2 runners. What should be the distance? It has to be how much? It has to be 3 feet, because your centering plate itself is 3 feet, isn't it? See, this was 3 feet, isn't it? So that is why when we keep that, no, will whatever is the size of your centering plate, based on that we are going to keep the spacing. Since the slab centering was the plate was 3 feet, we'll try to keep in between like 2.5 or 2.8 feet, so that you can keep your slab centering plates, right? Yeah. So these are the beam shuttering and these are the slab centering plates. All these are your slab centering, and the one you can see in the middle, no, going in the middle direction. All these are your beam shutterings. Yeah. So finally, this is how it looks. Now, see, this was your plain beam. You had casted, beam bottom was put up. Then this is your outside shuttering, and all these are your slab centering, right? All these are your slab centering. You can see it here. Everything is a slab centering. Again, you can see it here. All these are your slab centering. Beam bottom you have put up. Then you have put up the beam outside beam shuttering and the slab centering, right? Now, one question might have come in your mind: how to understand what should be the size of all these things, isn't it? Even I'll show you one more thing. See here. Finally, this is how it looks. Once you arrange everything, no, this is your beam. From here, the beam is going to come, and all these are your slab centering plates. And this is how we are going to arrange. Now we'll try to see a few of the structural drawings, and we'll try to understand all these things. So right now we are in the ground floor, right? So you have to refer a drawing which says that first floor shuttering layout, because right now I'm in the ground floor, but it is at the top level. So that becomes my first floor shuttering layout, or few people write this as ground floor shuttering layout. It's one and the same. It depends where exactly you are. Okay. Few structure consultant write it as first floor shuttering layout. Few people write this as ground floor roof slab centering layout. Getting my point? It's one and the same. Now come here. So you see this drawing now, and we'll try to understand. Yeah. So everything will be mentioned here. So this is the name of the beam is B1. The size is 9 inch by 15 inch. Then this is B2, which is 9 inch by 15 inch. Okay. Then we have B3, which is 9 inch by 15 inch. Then again B3, 9 inch by 12 inch. All these are the name of the beams, and whatever is the size of your beam, it is mentioned here: 9 inch by 15 inch, 9 inch by 15 inch. Okay, 9 inch by 15 inch, and so all. Then again you see here something is written, isn't it? 6 inch thick, 6 inch thick, 6 inch thick. So this is the thickness of the slab that you're going to put. As of now, we are not discussed about that, but whenever you see the slab centering layout, you're going to get the sizes of the beam, and also what should be the thickness of your slab. Both things you're going to get it here. So that is why you can see it's a 6 inch slab. It's a 6 inch thickness slab here. Again, here also it is 6 inch thick. Here also it is 6 inch thick. And then all the dimensions will be given. Got it? Similarly, I'll take you to one more. See here. This is one more drawing I'm showing you. Yeah. Again, can you read it out? All these are your columns. The one which is gray in color. This is gray. This is gray. And this is also gray. So the size, the name is B1, B2, B3, B4, and sizes is also mentioned. And this entire thing is your slab, and it's a 6-inch thick slab. Here also you can see it is a 6-inch thick slab. Similarly, here also it is 6-inch thick slab. So this is the entire layout. With the help of this layout, we'll try to prepare whatever we have done, no? The slab, the beam bottoms and all these things we are going to do. One thing, whether you have to use the Acro Span, all those things will not get. All this is a practice what we do in the site. No one will tell you whether you have to use Acro Span or not. Of course, if it is written in the BOQ, we'll follow that. But all those things will not get in drawings. Whether you have to use BOQ, whether you have to use Acro Span or not, what should be the center to center spacing of Acro Span, that is also not mentioned. And you have to do the casting of a column till the beam bottom. All these things will not mention in any drawing. It's a practice what we adopt. And as a site engineer, we should know all these things, right? Yeah. Now I'll take you to one more drawing. So this particular drawing is the same building what we are seeing, right? Now, if you see whatever slab centering you can see here, and whatever arrangement we have done it here, and whatever right now you can see this building, no? Yeah, this particular building. And also initially I had taken few images. Yeah, this entire building, right? So whatever your images you are seeing it here, these images are from the same drawing what I'm showing. So try to concentrate here, so you'll get an idea, right? See, so this is the entire layout what we have done. Yeah, so this is the entire slab layout. We'll try to understand it one by one. See, all these are your columns. The one which is red in color, no? This is column, this is also column, this is also a column. Everywhere it is a column. A red one is everywhere it is a column. Similarly, here has given a green color column, right? Again, here also it is green color column, a green color column. Similarly, you have a purple color column. You have a purple here, you have a purple here. Why is that? There is a change in the color because it will be easy for you to identify what are the different sizes. So what they have done is the one which is red in color, the size is, let us say, 9-inch by 12-inch. The one which is green in color, let us say the size of the column is 9-inch by 15-inch. The one which is purple in color, let us say the size is 9-inch by 18-inch. So it will be easy for you to identify on the site. That is why few of the structural consultant, they practice it in this way. Now tell me, I'll take this as a kind of assignment. Tell what is the name of this beam. The name of the beam is B7 and the size is 12-inch by 8-inch exactly. Now read out this beam. The name of the beam is B95. Tell me the size of this beam. It is a 12-inch thickness and 12-inch breadth and 18 inches the depth of it. Similarly, the name of the beam is B15 and the breadth is 12-inch and the depth is 18-inch exactly. B104, it's a 12-inch breadth and 18-inch depth. And what should be the thickness of the slab? It is mentioned 5-inch thickness. Now there's some symbol written here. We'll try to see what is the importance of all this symbol in the when we come to the slab part. Now this much is understood for us. So now based on this, you are going to arrange what should be the width of your beam bottom. What should be the beam bottom? In this case, it has to be 12 inches, 12 inches, 12 inches, and 12 inches. What should be the depth of your beam shuttering? It has to be 18 inches, 18 inches, 18 inches, and 18 inches. Getting my point? So in this way, this will tell the shuttering people what should be the breadth, what should be the depth and all. And based on that, what will happen? All these things you can see here, no? These guys are arranging all these things, the breadth, right? Similarly, you can see here how they arranged all these things, no? The beam bottom, these are the beam outside shuttering. What has to be a depth of this? Let us consider, to put it in a better way, I'll take one beam. Let us consider right now, I'm looking at this beam. It's outside beam, isn't it? So I'll take this beam itself. Yeah, consider this as that beam, B78. Okay, this particular beam represents this beam practically. I'll write it here. Yeah, this is B78. And what is the size of the beam? It is a 9-inch by 18-inch, I guess. Let me check it out. Yeah, 9-inch by 18-inch. Good. So it's a 9-inch by 18-inch. Now, practically, when you do this, what will happen? You are going to set the bottom for this beam. This beam bottom will be 9-inch for you. And this depth, what you are going to keep, no, it will be 18 inches for me. Getting my point? So this will be 18 inches for me, right? So in this way, you are supposed to do all this work. Again, it is not exactly 18 inches. When I come to the slab part, I'll tell you this small calculation you are supposed to do. Overall depth minus the thickness of the slab is going to give this height. This is the overall height, 18 inches. But when we put the shuttering, no, we have to deduct the slab thickness from this. Only then you can put the shuttering. As of now, understand that the breadth is 9 inch, the depth is 18 inches, And when we come to the slab part, I'll explain you. So by the time we finish, you'll be in a position to understand everything. Yeah. So I think the drawing part is understood. So in this way, now if I give you any drawing, you'll be in a position to understand that. Now you can take this as a kind of assignment and try to understand what exactly, try to imagine what exactly this looks practically on the side. Okay. And the thickness is 5-inch thickness, and all these are the beam, B110, B45, B117, and this is B51, right? Yeah. If you want, I can take you one more drawing. Yeah, it's the same drawing what I have. Yeah, we have seen 3 different drawings, and that is enough. Only the thing is you have to understand which drawing you have to refer. Right now we are in the ground floor, so I have to refer a ground floor shuttering layout, or sometimes people will write a first floor shuttering layout. That's it. And whatever is a layout, based on that, the execution will be done on the site. Yeah. Yeah. So I hope you have enjoyed the lecture up to here. We'll see you back in the next lecture. Thank you.